Okay, I'm going to do an example from page 253. Find all the real zeros. Now, when you have a problem like this, the first thing you have to do is figure out how many zeros do I have. So you have to take plus or minus 27, or the constant term, over plus or minus the coefficient of the highest degree term. In this case, it's a 1. If it's a 2, then you'd have to use plus or minus 1 and plus or minus 2 here and get all kinds of fractions. So the possible answers for this particular problem, when I figure this out, plus or minus 27, plus or minus all the factors of 27, so 9, plus or minus 3, plus or minus 1. So that's 1, 2, 3, 4, 5, 6, 7, 8 possible answers for this problem. Now, because there's an exponent 3 there, I know that it has a possibility of 3 real answers based on that exponent. Here, I have all those possibilities to test to see if there's a real number, it's going to be one of those for an answer. Now, in terms of guessing, I can also use Descartes' rule of signs, which says, first of all, on positive x, check the number of sign changes. So it goes plus to minus, so that's 1. Then it goes minus to plus, that's another, plus to minus. So there's 3 sign changes. So I could have positive roots, I could have 3, or less that by 2, or 1 positive root. Now, to check Descartes' rule of signs for negative roots, I have to put a minus x in place of all those x's and refigure that out. That means I have minus x to the third. Minus x there becomes positive, so minus 9x squared minus 27x minus 27. Now, for negative roots, check sign changes. Minus to minus, not a change. Minus to minus, not a change. Minus to minus, not a change. So that means there's no negative roots. So that's good. So now, in terms of guessing, I only have to take the positive roots there, and there's 4 positive roots that I have to try. I test these using synthetic. Descartes' rule helped me eliminate my guessing by half. So basically, since this has 3 real roots, there's probably going to be 3 positive real roots. So we're going to use synthetic, testing those numbers. Now remember, when you set up synthetic, you use the coefficients. So I need a 1, a minus 9, a plus 27, a minus 27. You with me there? And then I'm going to test these answers and see what I get. All right, so the numbers I have to try are 27, 9, 3, and 1. So let's just get those in a little box so I know what I'm working with here. I'm going to go with the 1 first because 1's easier to try. And so when I do this, bring down the first one. 1 times 1 is 1. Then I add, I get negative 8. 1 times negative 8 is negative 8. Plus 27 gives me negative 19. Minus 19 doesn't come up to 0. So I know that 1 is not an answer. And just for the record, I also tried minus 1 and it didn't work. So now I'm going to start with the next number. So the 1 didn't work. Oh, I didn't need to try the minus 1. All right, let's try 3. Bring down the 1. 1 times 3 is 3. Minus 9 plus 3 is minus 6. 3 times 6, negative 18. 27 minus 18 is 9. 3 times 9 is 27. Oh, I get a 0. That means that 3 is one of the answers to that equation. How many answers does it have? Possibility of 3 real answers. We found one of them. Now, once you get one of them, now I could try the 9 and the 27. But when you get an answer, you want to try it a second time from where you left off, because sometimes an answer is a double root. So we're going to test that first. Bring down the 1. 1 times 3 is 3. Minus 6. Whoops. Minus 3. Pay attention here. 3 times minus 3, minus 9. Oh, I got 0 at the end again. So that means I've got a second answer of 3. So 3 is a double root. I'm going to try 3 again, just to make sure it's not a triple root. So bring down the 1. 3, 0. Oh, it's a triple root. So I have all the zeros for that equation. Now, oftentimes you don't get a triple root to an equation. You end up trying all these other numbers until you get all of the answers to the equation. Now, the other thing you could do is once you get one answer, I could have stopped here at this point and written the equation, because I depressed the equation. This was x to the third. This is 1x squared minus 6x plus 9. And I could have tried to factor that. And I would get x minus 3, so x equals 3. I would have gotten those other two parts of the triple root that way. So you can also go back to factoring or continue using synthetic. You, as a mathematician here in pre-calculus, have lots of ways to solve problems. So good luck on solving these, and hope you can get some of the answers to the other problems. And that's it.